In this video, I will show you how to complete problem 31 from a first course in probability, 7th edition, chapter 1 on page 18. In this problem, we're told that there are 4 schools and 8 identical chalkboards that need to be distributed amongst those 4 schools. And we want to know the number of ways that we could distribute those 8 chalkboards to the 4 schools. Now, that question in part A is actually more difficult than part B, so let's take a look at part B first. In part B, we're told that we need to assign at least 1 chalkboard to each school. Now, this would be tantamount to taking those 8 chalkboards and putting lines between them, where the lines represent the cutoffs between the schools. So for example, if we bring in these lines here, that line would represent, the first line would represent having 2 chalkboards at the first school, and then the second line over, there's 3 chalkboards at the second school, and 1 chalkboard at the third, and 2 chalkboards at the fourth. As long as you have only 1 line per space, the gaps between the chalkboards, then you'll have at least 1 chalkboard for each school. So there's 7 spaces and 3 lines that need to go in. The 7, by the way, is the number of chalkboards, 8 minus 1, and the 3 is the number of schools, minus 1, 4 minus 1. So 7 choose 3 is the number we're looking for in part B, and that number is 35. Now going back to part A, it's a little bit more difficult question to ask what happens if you allow schools to not have a chalkboard. You see, if I stick 3 lines in here, and that big thick one is supposed to be 2 that are right next to each other, then we have to allow for more than 1 line in some of the gaps in order to distribute 0 chalkboards to any of the schools. And that's more difficult to allow for because you could have 2 or 3 lines in any of the gaps. So to make it a little bit easier, what I'm going to do is I'm going to give this school district an extra 4 chalkboards. So here's what it looks like now. Now I've got 12 chalkboards. But after I get done distributing chalkboards, I'm going to take back 1 chalkboard from each school. So I'm not taking back anything that they didn't have to begin with. So I give out my chalkboard. I give out 4 chalkboards to put in the pile. So now I have 12 chalkboards. I put my lines in now, and then divide up the chalkboards. The first school gets 3, the second school gets 1, the third school gets 5, fourth school gets 3. But then I take 1 chalkboard back, 1 chalkboard away from each of the schools, which will leave 2 for the first school, 0 for the second school, 4 for the third, and 2 for the fourth. Well, once you realize that that's one way to execute the first part of the problem is basically the same as the second part. I have 11 gaps between these 12 chalkboards, and there are 3 lines that need to go in. So 11 choose 3 is the number I'm computing, and that happens to be 165.